Hey there and welcome to the Code Wrinkles channel. This video will be all about webhooks, and the main reasons for this is that I think webhooks is something that we can definitely go 100% to when it comes to the .NET Minimal APIs. And the second reason why I think a video on webhooks is very important, because there sometimes might be some misunderstanding regarding exactly what webhooks are and what are they useful for. And to look into webhooks, I would like to start from a fairly big project that I have worked on a few years ago. So at a certain point, we needed to build an entire app ecosystem for a Swedish customer tailored for call centers around the world. Now, the core idea here about call centers is that there is really a lot of specific stuff. But one very common thing is that each call center is using a certain telephony provider. So what we needed to do is to create integrations for really most of those telephony providers. Now, when we created these integrations, there were actually two scenarios, and let me start from the first one. So a lot of different telephony providers, they just exposed a certain API that we can call and pull information to understand exactly what agent is in a call and what agent is on a break and what agent is maybe in an after call and things similar to that. So what we needed to do is we needed to continuously make calls to those API endpoints, get the data from there, compare it with the data that we had in our application, the state that we were holding on, and work out the deltas. Obviously, there was a lot of room for error here, and it is pretty cumbersome, isn't it? To put things into perspective, I have prepared here a very basic setup that tries to reproduce the exact same scenario that I have mentioned earlier. So first of all, we have this external service 2, which is the external provider. And then we have this our consumer, which would be the integration that we would need to write. Here what we have obviously is a controller in which we expose just one single endpoint. And through this endpoint, we just return a list of different agents, obviously each agent containing a different list of statuses. So if we take a look at our models, it's the agent, and this agent or each agent contains an ID and a list of call log, which is the activity, and this just contains a status and a date to start, so when this status started. Now, what we have here, we try to keep everything in memory to keep things simple and reproduce the scenario or the basic concept. So we have here an agent service that just creates a list of agents so that we have everything in memory and that we can update the activities for the agents. Now here comes the interesting part, because here we have this call service, which is in our case a background service that from time to time, here with a delay of 3 seconds, it will randomly update or add a new status to one of the agents. For instance, we just get the agents from our agent store, which is in memory in this case. And then what we do here is we get the last activity, and then we do some very basic cases. So if the activity was waiting call, then we would set the new activity to be in a call. If the previous status was in a call, we will set this to after call, and so on and so forth. So this happens in a background service each 3 seconds. So the consumers, they don't know exactly when a new status or when a new call log will happen to a certain agent. So they will have to continuously poll for this information. And that's exactly what we have done here in our consumer. Now, to keep things very simple, I have here the exact same models that we had previously. Like we have an agent with an ID and a list of call log, which represents the activity. So it's exactly the same. Now, the only difference here is we still have the same agent service, but in this case, we do not need to add initial activities. And then we have this call service. Now, this call service is a background service once again. And what does this service do? Well, each 2 seconds, it will make an HTTP call to our provider to pull some information for each agent, and then we'll display in the console some information about the new status of this agent. So that's basically it. Now, to see this or to put this into perspective and to understand exactly what the problem is, let me just run this external service first, and now also run our consumer. And here we will need to take a look at what happens in the console. So you see that here the background service continuously pulls the information from our provider. And in some cases, like for the first two occurrences, there was no information change. I think it's obvious there are a lot of downside in this approach, but we didn't have any other choice. That was the only option that those providers gave to us. Now, when we think about the downsides, the one very important downside is that in our case, when we did poll for the information, we didn't know exactly if that information was 100% accurate. This means that from the time that we were doing a poll and to the second poll, maybe there would be a status change twice or maybe 3 times. So it was pretty difficult to actually get it right, and there was quite some room for errors. So what we ended up having was also a lot of different background services that we were running from time to time and that were actually responsible to do some reconciliations. But the other very big downside here is obviously that there is a lot of HTTP traffic, and I mean really a lot. You can imagine if you have 1,000 different call center agents for which you need to poll status basically each second, there is a lot of HTTP traffic going on, and the main problem is in a lot of these HTTP calls you actually don't get any valuable information back because nothing has changed from the previous call. Therefore, can we do better than this? And the answer is obviously we can, and this is where webhooks actually come in very handy. But the thing is that the providers with which you work, they need to support this type of pattern. And fortunately, there were some telephony providers that kind of like exposed this type of working. Like the main idea when you use a webhook is that the provider says, you know what, instead of you polling me or pulling all the data from me and then calculate whatever you need to do, you know what, just register a webhook, a URL, and I will call that URL and give you the information that you want once something changes in your application. So now that we understand what exactly the core concept of webhooks is, let's move back to our application and try to rewrite everything so that we use webhooks instead of continuously polling for data. So to use webhooks, both the provider and the consumer need to support that specific pattern. So that's why we first need to perform some changes in our external service too, so that we support this idea of webhooks. The first thing that we would need to do here is create some new models, and let me add a new class here that would be status change, and it will contain this very basic information. Let's also add another new model, and in this case we will call this endpoint registration. And that's basically what the consumer will send us as a body when they want to register their webhook, but we will see this in action just in a few minutes. Obviously, in this type of contract, you would have to make sure that the consumers will provide all the needed information so that you are able as a provider to send them the appropriate information and not information that maybe belongs to a different customer. In our case, however, we'll keep things simple, and the only thing that we want to get basically for our consumer is the URI, the URL to which we need to make a request, a post request when we have some new data. To keep track of the URIs to which we need to send information, we'll also need a new service here, and we'll call this service Consumers Service. And in this one, we'll just keep here a track of all the consumers that have registered for us to send data to them, and we'll start by an empty list. Now we'll need to go back to our call service because there are some information or some new stuff that we actually need to perform here instead of just adding a new activity. First of all, we will need an HTTP client so that we can make calls to the webhook that consumers register with us. And to do this, we will obviously register an HTTP client factory. But we'll also need a consumer service so that we know exactly to which URIs we need to send the new information. So let me also inject this here into the constructor and create the HTTP client using the HTTP client factory, and then set also the consumers. Now the only things that we will need to change here is that when we add the activity, we also want right away to also send an HTTP call to our consumers. And to do this, we'll first have to create this new status change. So that's the model that we have created previously. And then we'll make sure that for each of the URIs that we have in consumer webhooks, we make this post as JSON async. We provide the URI, this new status change, and the cancellation token. And we need to do exactly the same things also for the other cases. And now we should be actually good to go with this. And to wire everything up, here we will also need to add an HTTP client so that we can use it in our call service. And we also need to add the consumer service as a singleton so that we can use it from our background service. And now comes the very fun part. because when we are doing or when we are supporting webhooks, there is this pattern that we should expose this post endpoint through which the consumers can subscribe or to register basically to our services, so that every time we have a new change for them, we know exactly where to send that specific request. So that's why we have here this app map post. And that's where really the .NET Mnimal APIs come in very handy, because when you're creating this type of registrations and webhooks in general, you just need to provide some code to run. You don't need all the ceremony for a controller. You don't need a lot of filters and everything that comes around the controller. You just simply need an endpoint that can be called easily and that you can use to perform a very quick and simple action. In this case, what we'll do, we will just add this request that comes in to our consumer webhooks so that we add it or we can use it to send information whenever there is a new information change. Obviously, if we give consumers this option to create or to register for our information, we also need to provide them a way to unregister. And that usually happens exactly through the same URL, which is this agent status, but instead of post, we'll have a map delete. And the map delete is very easy. In our case, we just remove that specific consumer from our consumers. Now let's move over to the consumer. In the consumer, first of all, we will need the exact same classes again to keep things very simple. So we'll have this class that's called endpoint registration, and this is what we will send as a body to our provider so that we provide them the exact URL that they need to call when there is some new information. And just like previously, this will contain just a simple URI. The next model that we need to create is the status change, which is what we will receive from our provider once there is new information. They will send us or they will call our webhook and they will provide us with this information. And it's exactly the same that we had also in the provider for this. Here we'll also need to tweak our call service. Now here we were already using the HTTP client, so that is okay. We'll still need the HTTP client and we still need the agent service. But what we don't need is this entire thing that we are doing here. To keep things simple, we will still keep this background service for now, but we will override this start async, and we will use the start async and we will use the stop async in order to subscribe or to register to our provider, or to register our webhooks to our provider and to unregister when this background service stops. So on the start async, what we do is we create a new registration with this endpoint registration, and that is the URL to which actually we want to receive the information. And then we use the HTTP client and we post async to the agent status of our provider, and then we provide the registration and the cancellation token. And then we just call the base start async method so that ASP.NET Core can configure anything else that they need to configure. Very similar to this, we will also implement this stop async method in which we call this HTTP client delete async because we want to unregister our webhook from our provider. Now the only thing that we can do here right now is to just remove this entire async method because we don't need it anymore. However, as part of this contract with this abstract class, we still need to implement the missing members. But for now, I'll just right here console write line and just have here written nothing here. Once again, don't take this really as the way that you need to implement it. This is a hack to keep things simple. We just need here a very quick way to register our webhook and to unregister our webhook. You would probably do this in different ways in a regular application, so don't really use this type of background service and just use this start async and execute async and throw an error or just write something in the console here. That is not really the way to go. You have different options that you can hook into the host startup and then maybe do the registration from there. So you will need to look into different ways of doing this because right now it's very hacky and it's not what I would advise. So let's go back to this program.cs. Here we'll also need to add our consumers service, and what we'll do here is we'll use once again the Mnimal API to provide our webhook callback. So we have this map post, so the provider will call our endpoint with agent status, and we know that it will have this status change in the body. Now what we do here is we use the agent service to get the agent based on the ID. Then we create a new call log, and if the agent is not null, we add this to the agent's activity. And then the only thing that we do here is we write everything in the console, like agent with the agent ID is on status and then the name of the new status. Now let's run our external service to wire everything up together and also our consumer. And what you notice here is that instead of polling data for all the agents all the time, we actually get back only the data that we need or that was sent us through the webhook by our consumer or by the provider actually. So in this case, the agent 3, agent 2, agent 2, agent 3 once again, and you see that agent 1 was all called only here. So once again, the idea is that we don't really do a lot of HTTP calls to get all the information for all the agents, no matter if it's changed or not, because we need to calculate if there is something changed. But right now we have the external provider calling our webhook whenever there is something new, and then we can do something based on it. In our case, we just display it in the console. To sum up, I'd like to say that when it comes to this concept of webhooks, there always needs to be an external provider that gives this option or that provides this type of functionality or pattern, and then there's you, the consumer. Now, if for some reasons you are both in charge of the service or the provider and the consumer, you could easily use a service bus or a message broker or something like that, because you control both ends. But on the other hand, it's very nice when providers give you this opportunity to just register some webhooks, and they will call and send you the information that you need once that information is available. Don't forget to hit the thumbs up button and to subscribe to this channel if you're for the first time here. And if you have any question, don't be shy and head over to the comment section and leave your comment. I would be more than happy to get in touch with you. This being said, thank you very much for watching, and until the next time, I wish you the very best.